Hi. So this is a problem related to capacitance. So here you can see a cube-like structure having 12 capacitance in each side. Okay, and their value of capacitance all are equal C. We have to find the equivalent capacitance between these 2 points. These 2 points are just opposite corners. Okay, so before that we can connect a battery or a cell between these 2 points. Okay, so this is our initial step. Then let us draw a plus q current from this positive terminal. This plus q charge, not current. Then this plus q charge will go in this direction. So we can see here this is a junction. Okay, from there three branches are going. One is this, second is this, third is this. Okay, so capacitance of each branch is same. So we can split this charge into three equal components, like q by 3, q by 3, q by 3. Okay, so we split this charge into three equal parts. Then this q by 3 will go in this direction, and again it will split in the next junction. This is next junction. So after again splitting, q by 3 will split again into q by 6 and q by 6. Okay, it is half. Q by 6 is the half of q by 3. So we get q by 6 here, q by 6 here. Also, when this q by 3 goes on this direction, it will split into q by 6, q by 6. Okay, and this one, this q by 3 will split into q by 6, q by 6 after going this direction. Okay, now we can see this q by 6 and this q by 6 will join here, and we get q by 3 again, like q by 6 plus q by 6 will give q by 3. Okay, next we can see this q by 6 and this q by 6 will join here, and we get q by 3 once again. And in last case, this q by 6, you can see this q by 6 and this q by 6 will join here, and again we will get q by 3. Okay, so finally 3 q by 3s are there, 1, 2, 3. So they 3 joined at B, and we get q charge, which will pass into negative terminal. Okay, so this is the second step in the process of finding equivalent capacitance. Okay, so next is we have to take the shortest path in which charge will move. So we can see that A, C, D, B. So this is the shortest path. So in which number of capacitance is minimum, that is 3. So let us take this path, and we know the voltage or potential difference across these capacitance will divide into three components, V1, V2 and V3 for these three capacitors. Okay, 1, 2, 3, because we took that direction or that path, shortest path. For V1 we can write charge by capacitance, we know V equal to Q by C. So here Q is Q by 3 by C. For V2 this one, charge is Q by 6 by C. V3 this one, Q by 3 by C. So Q by 3 by C, Q by 3 by C, that is 2Q by 3C. Okay, we can write this denominator and this denominator in common way, and Q by 6C. So on solving we get, after multiplying 2, yeah, we get 5Q by 6C as V. Okay, now let us take this Q into left side. Once again I will write V equal to 5Q by 6C. This Q will turn into left side, so V by Q equal to 5 by 6C. Let us take reciprocal, that is Q by V equal to 6C by 5. Q by V is what? Is our capacitance, equivalent capacitance. So equivalent capacitance is 6C by 5. Okay, so this is the equivalent capacitance when we take 2 points just opposite in this Q. So this is our next question on capacitance. So here we can see that apart from capacitance, 2 cells are there. Okay, 6 volt, 6 volt. Here we have to find the charge on each capacitance, each capacitor. Okay, so 3 capacitors are there. For this, we can once again take a charge plus Q from here, and okay, let us take Q1. Also, let us take plus Q2 from here, from 2 cells. So this Q1 will travel in this way, and this Q2 will travel in this way. Okay, Q2, Q1, and they will meet in this junction. So after meeting, they will get added. So Q1 plus Q2. This direction, Q1 plus Q2 charge will flow. Okay, so what's our next step? We have to write the equation. This is same as in the case of Kirchhoff's law. Okay, instead of taking current, we take charge. Now it is time to solve. So we know the potential difference or voltage equal to charge by capacitance. Okay, so if more charges and more capacitance are there, we have to add them. Okay, so in this loop the potential difference is 6. and the first capacitor is this 2 microfarad and the charge is q1. So q1 by 2. Okay, I am taking only 2, not microfarad. Let us neglect that now. Plus next capacitor in this loop is 5 microfarad, in which q1 plus q2 charge is moving. So q1 plus q2 by 5. Okay, so this is our first equation. Let me rewrite that like after solving this, 5q1 plus 2q1 plus 2q2 will get 60 here, then 7q1 plus 2q2. Okay, this is our first equation. So then we have to take this another loop. Again, remember this formula, potential difference is 6. Then going this direction, our charge is q2 and capacitance is 4. So q2 by 4. Add, the next is 5 microfarad capacitance and the charge is q1 plus q2. q1 plus q2 by 5. So again, taking LCM or cross multiplication, we get 120 equal to, I think 5q2 for q1. Yeah, 9q2 plus 4q1. This is our second equation. So these are two variable equations. We have to solve this to find q1 and q2. This simple mathematics you can do it in your own. Okay, so after solving, you will get q1 as around 5.45 and q2 around 10.9 microcoulomb. Okay, why microcoulomb? Because we take the microfarad, that's why we are getting microcoulomb charge. Okay, so solve this your own, these two equations, like you are doing in this, like some 5 or x minus 5 equal to some 10, and you will multiply a number or add or subtract like that. So this is our another question on capacitance. So here it is given that 100 volt is across A and B. So 4 capacitors are there, 6 microfarad. We have to find the potential difference between C and D, between these 2 points. Okay, so before that solving, we have to remember that when the potential difference between A and B is 100 volt, which is same as here also, this is also 100 volt between these capacitors. Okay, so let us take charge Q from here, and which will split from here to Q1 and Q minus Q1. Okay, because it's two kind of branches, so that's why taking Q1 and Q minus Q1. Okay, so this Q1 will move in this direction, all Q1. Okay, so let us write the equation for this loop. So here we have to remember that the current moving in, charge moving in this direction, or the potential across this direction, will be equal to potential across this direction. Okay, so we can write that here the first potential on this capacitor is q1 by 6 plus next q1 by 6, next also q1 by 6. Okay, which is equal to the potential difference across on this capacitance. Okay, so that is q minus q1 by 6, which is 100 volt, we know already. Okay, so we can solve this 3q1 by 6 equal to 100 volt. So q1 will be 200 microcoulomb. So on substituting 200 here, we get 600 microcoulomb as, 800 microcoulomb as q. Okay, now we have to find the potential difference between C and D, which is again potential difference across C and D equal to, again, charge by capacitance. So charge is q1 by capacitance is 6. So q1 200 and capacitance is 6, or 100 by 3. So this is the potential difference across C and D.